We've talked about inequalities, but what happens if we don't want to just split the number line into two, greater than 5, less than 5, that kind of thing, but we want to define a more specific range of numbers? For instance, what if I only want to talk about numbers, say, between 5 and 11? Okay, then we use these things called compound inequalities, and they look like this. If I want to talk about the numbers between 5 and 11, I would say x is greater than 5 and less than 11. Or if I wanted to talk about the numbers less than -1 and greater than 1, I would say x is less than -1 or x is greater than 1. These are our two types of inequalities, the and inequality and the or inequality. So in the and inequality, both of these things has to be true. It has to be greater than 5 and less than 11. In the or inequality, it has to be less than -1 or greater than 1 to be included in the rule that we've defined here. These are what we call compound because they're sort of putting together two types of two inequalities, either as in an and statement or in an or statement. So where might these come up? Well, these might come up in, say, cooking directions. Something might say the time a cake must bake is between 25 and 30 minutes inclusive. So that means that the time, t, that the cake needs to bake has to be greater than or equal to, because it's inclusive, 25. Inclusive means also could be 25 minutes. Or less than and equal to 30 minutes, which is to say if it hasn't cooked for at least 25 minutes, it's not going to be done. If it cooks over than 30 minutes, it might be overdone and you might burn your cake. So the directions say is between 25 minutes and 30 minutes inclusive. This is an and compound inequality, right? Because both of those rules has to be true. So what kind of times would work? Well, 26 minutes. 25 minutes, in fact, would work. 27, right? 30 minutes. All of those times would work as long as they're between, inclusively, including 25 and 30 between those two markers. And you can solve compound inequalities a lot like you would solve a normal inequality, but you have to deal with all sides of the inequality at once. So whatever you do to one part of the inequality, you have to do to all parts of the inequality. For instance, if I want to isolate k here, I've got to deal with this -2 because k minus 2 is in the middle and I want to isolate k. So to deal with this -2, I have to use the inverse operation of addition and add 2. But I can't just add 2 to one side, whichever I pick. I've got to do it to all parts of the inequality. So now it's 7 is less than or equal to k, which is, or 7 is less than k is less than 13. So notice that it's not like an equation where I only have to deal with the two halves of the equation. In this case, I've got to deal with all parts of the inequality when I go to solve it. Here we've got an or compound inequality. With the or compound inequalities, you just solve them one at a time. I'm going to start with the one here on the left. 3d plus 3 is less than or equal to -1. I'm going to do that by subtracting 3 from both sides. So I have 3d is less than or equal to -4. Divide both sides by 3. And d is less than or equal to -4/3. Then I just simply go on to the next inequality and solve that. Subtract 2 from both sides, and I have 5d is greater than or equal to 10. Divide by 5. Divide by 5. d is greater than or equal to 2. And this maintains an or inequality. So d is less than or equal to -4/3, or d is greater than or equal to 2. So with the or inequalities, you just solve them like two separate inequalities, just like you would any other inequality. Here we have another compound and inequality. And I wanted to bring this one up because in this case we're going to have to multiply by a negative to get rid of this division by the -4 here. So if we want to multiply by a negative, remember from our solving inequalities section, we must flip the signs. And I just wanted to show you that it really works the same way, except we're going to be flipping two signs instead of one. So if we multiply everything by -4, we get -12, and then we flip the sign, so less than 11 plus k, because those -4's just cancel out. 11 plus k is less than or equal to positive 12, because negative 3 times negative 4. So really, it's the same process as we did with just a normal inequality with a compound inequality, except that you flip both signs. And then we subtract 11 from everywhere. And we get negative 23 is less than k, which is less than or equal to 1.